Hey everybody! Today's practice problem comes from Principles of Microeconomics by Dirk Mateer and Lee Kopic. Today we're going to be doing Chapter 7, Problem number 8. The problem begins as follows. It says, two companies, Toxic Waste Management and Sludge Industries, both pollute a nearby lake. Each firm dumps 1,000 gallons of goo into the lake every day. As a consequence, the lake has lost its clarity and the fish are dying. Local residents want to see the lake restored, but toxic waste production process depends heavily on being able to dump the goo into the lake. It would cost toxic waste $10 per gallon to clean up the goo it generates. Sludge can clean up the goo at a cost of $2 per gallon. And then it goes on to ask some questions, but the first thing that we want to do is to, in fact, organize our information so that we have it here. So let's just call our two companies. Let's call them Toxic and Sludge. And there are a few things that we want to keep in mind. We want to keep in mind that before anything happens, we can say their status quo pollution, how much they're polluting right now. We were told that each of them were polluting 1,000 units. So we could put 1,000 and 1,000 here. And then the other thing that we were told is that we had a per unit cleanup cost that was different for the two firms, right? So then we could say the cleanup cost said here for Toxic, it was $10 per gallon. And I'm just going to put $10 because we understand that our units are consistent, that this is in gallons and that this is in dollars per gallon. So we have something like that. And then we were told that Sludge's cost was $2 per gallon. So a good first step is to just organize the information that you have so that you can figure out what you have and what you should be doing with it. And then the next part of the question says, if the local government cuts the legal goo emissions in half for each firm, so then we could say new pollution allowed. Well, if this is cut in half for each firm, then Toxic would have to cut by half and get to 500 units of pollution or 500 gallons of pollution. And Sludge would also have to cut by half and get to 500. So we'd have something like that. And then it says, what are the costs to each firm to comply with the law? So we could say here, what's the cleanup cost, not per gallon, but as per what we'll call Law 1, because as we'll see, we're going to get to a Law 2. And we can say, well, think about what's happening here. What's happening is that this firm, we're not multiplying directly by 500. We're instead asking the question, by how much does each firm have to reduce its pollution? So really the relevant quantity is the difference between this status quo pollution and the new pollution allowed. So if we were going to calculate the cleanup costs for Toxic, for example, we'd say they have to clean up by 1,000 minus 500 gallons. Just what they were doing minus what they're allowed is how much they have to clean up by, times the cleanup cost per gallon, which is $10. And we would see that 1,000 minus 500 is in fact 500 times 10 is going to be a cleanup cost of $5,000. And we could notice here, we could generalize this. We could have a formula that you could just plug things into. We could say that the cleanup cost in total, meaning not per gallon, is just the current pollution level minus the allowed pollution level times the per unit cleanup costs. that that's just what we were doing, right? That we say, how many gallons do we have to clean up? That's given by this quantity here. How much does it cost to clean up each of those gallons? So we could do this. Now you could see how we could just plug into this formula for sludge's cleanup cost. And again, we could then just say directly, sludge's current pollution is at 1,000 gallons. So we could just put 1,000 here. Sludge's allowed pollution was also 500. Times the per unit cleanup cost, which we said was just $2. So you just put $2 here. And what we're going to see is this is going to give us 500 times $2, or $1,000. So we can just plug things into this formula if you want to keep this formula in mind. One thing to notice, however, is if you're in a situation where you don't have to clean up. So if your current pollution is actually less than the allowed pollution, be careful that you don't blindly go ahead with your calculation and calculate a cleanup cost that's negative, because logically in that situation, if your allowed pollution is actually bigger than what you're currently doing, your cleanup cost basically by definition is 0 rather than a negative number. The question then asks, what is the total cost to both firms in meeting the GU emissions standard? So we could add a line here. We could say total, and we could think about which of these quantities are additive and which ones aren't. So their total pollution, well, that would be additive. Collectively, they're polluting 2,000 gallons. The cleanup cost doesn't really make sense to add, right? Because for them to clean up a gallon together, it's not like it costs them $12. The new pollution allowed, however, is additive, that collectively they were allowed to pollute 1,000 gallons. And in fact, the cleanup costs also are additive. So collectively between the two firms, the cleanup cost was $6,000. And then we can see the next part of the problem. It says another way of cutting GU emissions in half is to assign each firm tradable pollution permits that allow 500 gallons of GU to be dumped into the lake every day. So what we could do instead is we could say, again, we have these two companies. We have Toxic and Sludge. And we could say how many permits were they issued. And this is sort of a weird thing to think about. But if each of these guys are issued 500 permits, basically what that's saying is we're now in a world where in order to pollute 1 gallon, you need a permit to be able to do that. So these guys, if they're issued 500 permits, they can either say, okay, I'm going to get my pollution down from 1,000 to 500 and use all of my permits, or I could get my pollution down by something less than 500, in which case I don't have enough permits to legally be polluting that amount, but I can buy those permits from somebody else. Or they could even say, it's actually pretty easy for me to reduce my pollution, so it actually might be more profitable to reduce my pollution by more than I have to so that I have extra permits left over, because then I can sell those permits, right? So that's why this issue of, sometimes it's referred to as cap and trade, or this system of tradable permits, actually gets us to a more efficient cleanup solution than just telling each firm, oh, hey, you have to clean up by the same amount. That what these tradable permits actually do is encourage the firms for whom it's easiest to clean up and then sell their extra permits, and those firms for whom it's expensive to clean up, to not clean up as much and to buy some of those permits. So we can think about what's going to happen in this case. So firm Toxic, we can think about, two things. We can say, what is each firm's willingness to pay for a pollution permit? And we can also think about, what is each firm's willingness to sell for a permit? and this is just, of course, what's the minimum price that each firm would sell a permit at. And this is, of course, what is the maximum price that a firm would pay for a permit. And what we'll notice is the following. We say, well, these willingness to pay and willingness to sell numbers are going to be related to these cleanup costs. Because if it costs me $10 to get rid of a gallon of pollution, then I would pay up to $10 for a permit instead. Because if I could buy a permit that could allow me to keep polluting that unit for $8, that's going to be more profitable than spending $10 to clean up that unit of pollution. You know what I'm saying? So for that reason, the willingness to pay for the permits is going to be $10 for toxic, and it's going to be $2 for sludge. Because if the prices go above these amounts for each of the firms, they'll find it cheaper to just clean up rather than buy a permit. A similar concept holds for willingness to sell. We say, well, what's the minimum price at which these guys would be willing to sell a permit? And again, that's going to be related to the cleanup cost. Because we can say, again, for sludge, well, it costs me $10 to clean up. So if I'm going to clean up rather than use one of my permits so that I can sell the permit, I better be getting at least $10 for that permit, right? So their willingness to sell is also going to be $10. And by similar reasoning, the willingness to sell for sludge is also going to be $2. Because if it costs sludge $2 to clean up, then if they can get a price for their permits of more than $2, say, oh, I'll clean up some more so that I can sell the permits. That's going to actually be more profitable for me. And it's not surprising that the willingness to pay and willingness to sell for the two firms is actually the same. Because what we notice is that willingness to pay and willingness to sell on some level both represent the value of the item. And the value of the pollution permit to toxic is $10, and the value of the pollution permit to sludge is $2. So we can think about what's going to happen once there is actually a market for these permits. So the funny thing about markets is that they get resources to the parties that value them the most. So what's going to happen in this market is toxic is going to be like, I see that it's pretty easy for you to clean up. Let's think about a price that's going to be beneficial to both of us to trade. And actually at any price between $10 and $2, I guess more accurately between $2 and $10, it's going to be profitable for toxic to buy the permits and for sludge to sell the permits. You know, for example, say they agreed on a price of $5. Sludge would say, yeah, I'll sell to you for $5 because I could totally clean up for $2, sell you the thing that I was going to use if I didn't clean up and be $3 better off. Similarly, toxic could say, well, it cost me $10 to clean up. It's cheaper to just actually buy the right to pollute from you for $5 instead. I'm $5 better off. We don't actually know what price they'll arrive at. We just know that it's somewhere between 2 and 10. It's going to be based on the relative bargaining power, negotiation skills, etc. But nonetheless, if we were to think about the transaction that's going to happen, it's going to be the case that toxic is going to buy 500 permits, and it's going to be the case that sludge is going to sell the 500 that it has, right? So we could then say, well, what's the new number of permits? And that's pretty straightforward because toxic was given 500 and then they bought 500 more. So toxic now has 1,000 permits. Sludge was given 500, but they sold them all. So now they have 0. Easy. So then we could think about the next step, because ultimately what we're trying to understand is after this trade happens, what is the cost to each of these firms to actually reduce pollution, right? So then we could say, what is the number of cleanup gallons needed? Well, if Toxic was originally polluting 1,000 gallons and it now has 1,000 permits, it doesn't need to clean up at all. If Sludge was originally polluting 1,000 units and doesn't have any permits, it can't pollute at all. So it actually needs to clean up all 1,000 gallons that it was polluting. So as a last step, we could then say, what is the cost of cleanup for each of the firms? Now, if Toxic doesn't have to clean up, the cost of cleanup is $0. And if Sludge has to clean up 1,000 units, its cost of cleanup is just 1,000 times the cost per gallon. So just 1,000 times $2, or $2,000. But that's just specifically the cost of cleanup. We also want to take into account, we want to say, well, what's the total cost to each of these firms? Because there was not only the cost of the cleanup once the permits were traded, but there was in fact the revenue and cost from trading the permits in the first place, right? So we could say the total cost to Toxic was in fact the cost of cleanup of $0 plus the cost of the permits. And the total cost to Sludge was $2,000. And this is totally weird because I'm going to say $2,000 minus the revenue from the permits. And that works because if you think about it, revenues and costs are just two sides of the same coin. So costs are negative revenues and revenues are negative costs. And you can think about why that might make sense. Because say hypothetically that Sludge got $1,000 of revenue from selling the permits, then it would make sense to say that its total cost of cleanup was $2,000 from the actual cleanup minus the $1,000 that it got from selling the permits for a net cost of $1,000. That's why we subtract this out here. Interestingly enough, if we were to think about now the total costs to society from cleaning up, we would just add together the total cost for each of the firms. And what we would get is in fact just $2,000. And that's simply because, think about how these two things relate to one another. They have to be the same. Because whatever Toxic paid for the permits is whatever Sludge got for the permits. There was no friction in there. There was no tax. There was no third party involved. So these two numbers are going to be the same, so they're going to cancel out, and we have a total cost of cleanup of $2,000. The last part of the question asks, under this approach, under the tradable permits approach, will each firm still dump 500 gallons of goo? That answer is no, right? Because after they traded the permits, we saw that Toxic was dumping 1,000 gallons of goo and wasn't cleaning up at all. And we saw that Sludge was cleaning up entirely and not dumping any goo. And this example actually illustrates the whole point of the efficiency of tradable permits. Because by allowing the firms to trade, we got to a market outcome where the people for whom it was cheapest to clean up are the ones actually doing the cleaning up. And the numbers that are reasonable and relevant to compare here are the costs to the two firms collectively of cleaning up. And we saw in the case where we just put down a strict mandate that each firm has to clean up by 500 units to get to a new pollution level of 500, that cost the two firms collectively $6,000. Whereas when we gave them the permits and we allowed them to trade, the collective cost between the two firms was only $2,000. So the tradable permits actually got to a more societally efficient way of curbing pollution.